A very good afternoon and warm welcome to all the attendees and panelists. I am Nikhil Pampattiwar, the host of this webinar. I'll be introducing you to the topic and speakers. We all know the biggest challenge every food processing industry faces these days is the lack of advancement and innovation in its manufacturing practices. Now, to bridge this upgradation gap, we at Neologic Engineers decided to present the Emerging Food Tech webinar series. So in this webinar, we will talk about cost-effective food processing automation solutions, applications of top-notch machineries and technologies, current trends and future directions in the food processing sector, and many other things. We have been conducting these webinars from last 3 years, and in this 21st webinar of this series today, we will be talking about hygienic plant design and automation in beverage industry. A few words about our today's first speaker, Mr. Ankit Sharma, business unit head in beverage segment at Neologic Engineers. He's a seasoned chemical engineer with around 2 decades of experience in the beverage industry. Throughout his career, he has specialized in providing technical solutions for beverage processing applications such as process optimization, automation, and quality improvement. He has worked closely with leading MNC companies, delivering projects that streamline operations and strengthen their market reach. His unique blend of engineering expertise and industry insights has made him a trusted partner for delivering end-to-end solution in the beverage sector. Welcome to the session, Ankit sir. We look forward to your valuable inputs. Let me also introduce our second speaker today, Mr. Ravindra Mahajan, founder director at Neologic Engineers. He was born in middle-class family in Jalgaon, Maharashtra. He started his entrepreneurial journey and his association with dairy industry in the early age of 13, when he started selling milk early morning before going to school. He has masters in dairy and food engineering from IIT Kharagpur in 1991. With over 3 decades of process engineering excellence experience, including years in Alfa Laval and Tetra Pak, he established his dream by founding Neologic Engineers with his fellow associate Mr. Rajendra Gore in 2007 to provide end-to-end solution for various applications in dairy and food processing industry. Professionally a hardcore technocrat, PMP certified professional, having expertise in process design, plant automation, dairy aseptic systems, project management, and he has traveled to more than 30 countries and almost all the part of India for his professional work. So, ladies and gentlemen, let me present our first speaker today, Mr. Ankit Sharma. Over to you, sir.
Thank you, Nikhil.
Welcome.
So, very good evening to all the participants. So today we will explore the topic of hygienic plant design and automation in beverage industries. To set the context, we will discuss on how hygiene transforms the backbone of every successful beverage plant. And we see how hygienic plant look like in how we do it. With growing demand and lot of customization and diversified products, we understand how automation will help in providing reliable and consistent products. And at the end of the presentation, we will have some sort of a glimpse of smart technologies which are trending now in beverage processing world. So coming to the topic, why hygiene? So let me give you a task. So imagine that you are standing at a corner of a road and you want to have a tea. So which tea shop will you prefer? The left one with traditional tea shop with old kettles and rustic stoves, or the modern one with all hygiene and automated equipments? My answer would be I will prefer the right one, the modern tea shop. Why? Because it gives me a peace of mind on product safety, consistent quality, operational efficiency, and somehow I think it would be certified by FSSI. So I am assured that it is compliant to some product and safety standards, and with some these quality parameters, some sustainability will also be observed in the current shop. Now, again, I give you one more task. Imagine that you are standing in a beverage process hall and you are walking in the beverage plant process area and you are seeing glossy tanks, shining pipes laid neatly across the structures. And you will say, wow, this is the plant. But my question to you is, does the shiny or the shine truly ensures hygiene? My answer is no. A plant hygiene cannot be guaranteed by appearance alone. So what factors or what pillars which would lay the foundation of hygiene in the beverage processing plant? So today we will discuss four pillars of high of the foundation of hygiene in the beverage processing plant. First, the process design. Second, the equipment layout. Third, the equipment design. And fourth, the most important, the integration of all the three above, the hygienic installation. So, coming straight to the process design part. So, what is process design? Process design defines how your raw material, ingredient, and cleaning solutions flow through the system hygienically. It ensures the process is efficient, safe, and compliant with the hygienic design principle. So, process design answers three questions: what to produce, how much to produce, and how to produce. So, first two questions: what to produce and how much to produce. What to produce means what product you want to process, like juices, carbonated soft drinks, special beverages, juices with chunks, particulates, and their physical chemical properties like the flowability of the liquid, density, viscosity, acidity, or the Brix level, or the salt content into it. Then the third main characteristics which define the thermal treatment is in which packaging format you want to pack this product, like in aseptic packs or in aseptic PET or in hot fill bottles, RGB bottles, or retort standing pouch. So these three parameters will define the characteristic of your product. And the fourth one, the production capacity, will give us the direction whether the plant will be running in one shift operation, two shift operation, or would be running in a continuous mode, which will further enable us to design a batch type operation or a continuous one. Okay. So the product defines the required hygienic class and flow configuration. So now once you have okay with what to produce and how much to produce, now we come to the point how to produce. So how to produce is basically development of a process in which the flow of raw material is required. So the reception of raw material in which format is coming into the plant and into which state that is coming into the plant. Like either it will come in powder state like pectin is coming in your plant, or in liquid state like concentrates are coming in your plant, or pulp or chunks Pulp may be in frozen format, or maybe in aseptic bags, or maybe in drums. So, basis on the raw material reception, we will further design and develop our process flow diagram. So, once you have the raw material in place, then it requires processing and pre-processing of it. Some requires unit operations like filters, filtrations. Some requires heating, chilling. Some requires blending. And then once your system is in place, the cleaning of complete system is ensured by designing the CIP loops and SIP loops. Okay. Now coming to one more important point. Once your setup is complete and your unit operation is aligned, you want your product to be quality assured and safety assured. So we are then introducing product quality checks and product safety checks in the complete process, like a temperature, even a small temperature transmitter will help you to understand the nature of your beverage for a prolonged time, and which will be further sent to a pasteurizer for juice processing and further filling. Even we are doing product safety checks across the heat exchangers by applying positive pressure monitoring system, which is also a critical control point. And in short, we are now certifying your process as per the HACCP norms. So once your product process design is done, process design also offers one more additional features, is classification of hygienic and sanitary zone. So based on the level of operation and product safety requirement, the product, the uh, hygienic boundaries are laid down. Like the pulp handling area is being segregated from your main blending system, and like your UHT or aseptic system are being lied into a restricted entry zone because it is classified into a intrinsic hygienic zone. So this is how the complete process flow diagram looks like. So what we achieved by doing a process design. So we understand the flow of raw materials. Then we, basis on the production requirement, we design the filter, the unit operation associated to it. Then we put in the product and safety checks, and we are also setting the hygienic boundaries. By that, we are effectively utilizing the plant. This plant offers flexibility, so you can run many products or multiple products in the same system. And since these plants are hygienically designed, it will create lesser load on environment. And the and there would be a since as a beverage manufacturer, you are assured about the hygienic classification or hygienic design. You can again promote for innovation and product development. So in short, process design offers you a flexible and hygienic platform to process your product. But do you still feel that a good PNID, a good process flow diagram, or does only an accurate process design ensures hygienic beverage plant? No, because it is only the first pillar. Second comes the equipment layout. So once your hygienic boundaries are laid, the place of equipment takes place in the manner which do not hinder the free movement of material. So we develop a equipment layout. So equipment layout are generally unidirectional product. So it has a unidirectional nature into it. So if you visit any advanced beverage manufacturing plant, you will see a raw materials area, you will see a process area, and you will see a packaging area segregated. So there would be a uniformity that the product will come, the raw material will enter, it will get processed, and it will be packed as a product and then sent for further distribution. So it avoids any crossing points, and all the machines are being designed agronomically for maintenance and services. Even the utilities are designed so that it will not hinder the basic movement of the goods. So we have discussed process design, we have discussed equipment layout. Now post process design, post equipment layout, there comes the selection of equipments. So that falls into the category or the pillar equipment design. So the first thing that you need to select, the first thing you need to select for an equipment design is material. So material selection is based on the product characteristics like acidity, salt content, and based on that, to prevent corrosion, because it has to run for a longer time. So based on that, the product contact part has been decided. So suppose you need to go for SS304, SS316, or if you are having a higher ionic content in your product, then you go for some high grade special alloy material. Then these systems or these contact parts are also having elastomers, gaskets, O-rings, which are also in contact with the product. So these elastomers are also be ensured that it follows the hygienic protocol and are to be approved by any hygienic authorities like FDA, and we will be using along elastomers like EPDM, FKM, PTFE, etc. Then comes the cleanable geometry. So cleanable geometry ensures that our equipments are thoroughly sanitized, preventing contamination and maintaining product safety. So the key features of a tank includes a sloped tank bottoms with drainable outlet. Then it should not have any sharp corners so that there won't be any accumulation at the corners. Then these plants or these equipments or these components should be easily disassembled so that you will it is quick for it is accessible for quick maintenance. In case of blending tanks, the L/D ratio should be maintained so that there should be a uniformity of flow in the tank. And when you are having agitators or any other mixing devices in the tank or in any of the components that you are selecting, you ensure that there should not be any blind spots, or so that the every corner or every area of the component is cleanable and drainable. So here we are enforcing drainability and cleanability in the geometry of every equipment that we are classifying for a beverage processing plant. Then the third selection would be product surfaces. Product surfaces must be designed to minimize the contamination risk. More the smoother the surface, lesser would be the addition of microbes on the surface, and more we will ensure that the uh, design or the equipment is suitable for ultra hygiene or a hygienic requirement. So there is a parameter called as point a micron RA value, that is the degree of roughness which has been standardized, and it should maintain at least below zero point 0.8 micron RA for all the process equipments that are being delivered in the process hall. We also need to understand that all the components should not have any joints into the uh, into the equipments, and if there is any gaskets or crevices there, we should ensure that it should be smoothened up. So far as welding is concerned or metal to metal contact is concerned, we prefer welding, because post welding we will be polishing the surface, and which ensures that the surface is smooth and there is no crevices or there is no any sort of pitting formation across the welding area. In some cases you may not be able to avoid the welding, or you welding is not possible, then we will ensure that the gaps or the crevices should be filled with the elastomers, so that it is be completely blind off and it is even 100% cleanable. So, basis the equipment design, what we have observed is that we have selected the material based on the product classification. Then we have attained that the component which we are selecting is cleanable and fully drainable. And then the product surfaces are smooth, and all the weld joints or any other joints are smooth and cleanable. So this ensures that the components are meeting the global hygienic standards, and it ensures that the product is uh, safe, and the product and the quality of the product processed through these components will be good. And the it also ensures that 100% cleanability and cleanability is assured in these equipments to be designed. So by these three outcomes, we ensure that it will increase the productivity, because the good equipment will create good experience with lesser breakdown and a longer availability for production. Still, I am saying, we does a good PNID, a good layout, and a good GA drawing of a tank or a pump or any equipment design guarantee you that you are having a hygienic beverage plant. Still, my answer is no. Why? I think it has been explained by Mahajan sir in the next slides, because it is the important topic where we are integrating all the three aspects in one setup, that is called hygienic installation.
Right.
Over to you, Mahajan sir.
Thank you, Ankit. Great. So basically, now we have ensured the three steps. The fourth step is also very much important, and by missing any of these steps, we are compromising the hygienic design of the plant. So we have to ensure that process design, equipment layout, equipment design, everything is done in a hygienic way. Same way, the hygienic installation and reliable control. These are the two factors. These are very important. What is mean by hygienic design is, let us see in the next slide. So the equipment positioning we have discussed, ergonomic spacing for accessibility, use ball pit. We should have the approachable areas everywhere under the tanks, under the modules. It should be accessible for cleaning, and there should not be any chance for accumulation of unwanted garbage. Also, we have to ensure that drain points are clear and not going under the equipment. There is no water stagnation on the floors, and there is no water stagnation inside the trays or drain points that we have given. Material handling during the installation is also very important, because even if we are using a very good quality material, if we have mixed SS304 and 316, it's impossible to visually uh, identify the difference between the two material. It is also possible that the installation is going on with side by side with mild steel, and the same types of tools are used on stainless steel and mild steel, or the material is stored together, the utility pipes are stored together. So we have to avoid all these kind of mishaps, because contamination of metal is risky on long term basis. Next. So hygienic welding procedure, even though we have selected very good hygienic pipe and components, but if the welding is not proper, then there is a challenge. So first is to avoid misalignment. The ODs, outside diameter as well as inside diameter of the pipes, fittings, valves must match. Our instrument connection must match. There should not be crack in the welding joints. The welding has to be quite smooth surface. There is no porosity in the weld joints. There is proper gas. The purity of argon is very important. Uh, Completely the oxygen from the inside of the pipe also should be removed when we are doing TIG welding or pulse TIG welding or orbital welding. We have to ensure completely inert atmosphere with proper purity of argon. 99.99% argon purity has to be there. Otherwise, you get the defects as shown in the photographs here. And this is a very bad quality of welding, but these are the samples. You won't believe, but these are the samples from the plants. Sometimes the welding is done with electrode in emergency, and nobody then replaces it. Yeah, next. So pipe work installation and support is very important. What type of reducers we are selecting? What type of dead ends are created during in the piping? If the dead end is more than 1.5 D, then definitely there will be a stagnation that in that dead end that will not be removed even after the good CIP. So we have to ensure the flow as shown, that the flow should be proper, dead end should be drainable. There has to be sufficient uh, supports, pipe supports at proper distance, so that there is no sagging of the small diameter pipes. The pipelines are properly supported, not supported on the equipment, and not under tension. Otherwise, eventually it will crack. The rubber parts will worn out, and leakage will start. So these are the points very important. Next, component installation. Like when we are installing the pumps, we have to ensure that it is properly drainable. We have to install the T joints or instruments in such a way. If you see the instrument near the homogenizer, generally we put instrument and its matching connection, but we don't see the dead leg there. So it is best way is to have the instrument with hygienic connection coming from the supplier for the proper design diameter of the pipe, so that we don't have to do any adjustment at site and creating dead ends. Next. So equipment positioning, material handling, hygienic weld joint, pipe work, component selection ensures that the plant is fully hygienically designed and validated for process room. Efficient cleaning and maintenance is possible. There is a very low risk of contamination, and it is compliant to food safety standards of installation. The plants that we do, the component that we select are always EHEDG compliant or 3A compliant, depending on the country where we export. Next. So accurate design and installation ensures, now we can say, out of after following these rigorous 4 steps properly, and with it is done by competent team, then we can say yes, now the plant is designed, yeah, and the installation is hygienic. So how do we do it? Now we have understood the theoretical part, that what is expected and how it should be done. But how do we do it? Let's see that. So we create the effect is that we create a very hygienically designed piping installation drawing well in advance in our office with proper 3D modeling. And it is not just for construction, but before construction, we do the food safety audit of the installation design in office. Like we do the FAT testing of the automation. Similarly, we do the hygienic risk assessment of the piping design. And once it is done, then we expect that there are minimum changes at site, because uh, it is important to have the proper correct civil drawing or building drawing as an input material to us. One more important point is we are concentrating only on SS piping, instruments, SS equipments. That is not enough. It is also required that the hygienically designed supports are there for utilities. The utility supports, utility drop-down connections, everything has to be hygienically designed. Otherwise, everything will be back to square one. There will be so much of dust accumulation areas, dirt areas in the utility piping, that you cannot say that again the plant is hygienic. So, when we take a project, we ensure that the utility piping is also hygienically designed by us as a part of the complete solution. Even if it is not sometimes not executed by us, but the design is has to be through one central agency, so that there is an overview of the hygienic risk. Okay, next. So these are some of the photographs. Sorry, 3D models. How we do it. How we check each and every point. Now, for example, filters. Filters have to be 100% renewable. The walls, the trays below the walls are drainable to the drain points. Everything is important. Next. Our next topic is why automation. Why now, if the plant is hygienically designed, but what about the controls? If the controls are very basic, then still there are chances that product safety is compromised. There are chances that CIP is compromised. And a compromised CIP means compromised production. So there is a very much need of automation. And nowadays, we see a change, a drastic change in our customers' mindset also, that everybody wants to upgrade for automation so that they have peace of mind about their product, about their brand image. Next. So let us see why automation. See, this is a basic plant where we have very basic piping, and it is many times difficult to track and remember which piping was earlier CIP clean or which was not clean, which was used for production, which was used for CIP. And there are some loose bends. Those loose bends are lying in the floor or in the a tray or some plastic cabinet somewhere, and then we connect. So there is a lot of manual handling, manual contamination coming through hands, coming through the dust and all. So a tendency is to always go for fixed piping with mixed proof valves. Mixed proof valves give as a complete foolproof solution, so that CIP and production cannot mix together. It also gives us a flexibility that without changing the bend, without having a stopover of the continuously running line, you can change the tank, you can change the destination, you can change the source, or once one tank is full, you can put the second tank in the queue, so that without stopping the production or blending line or homogenizer, you can still fill up the next destination tanks. So this will increase the productivity as there are quick changeovers. And another inherent advantage of automation is you can do a predictive maintenance. Our software can count how many times the valves have opened, how many times the instrument has been calibrated, and we can then do the predictive maintenance report, so that maintenance is done well in advance and there is no breakdown. Yeah, next. So is automation only limited to change over from manual panels to valve cluster? Definitely no. There is much more to it in automation. Let us see how it is. So we come across many times in juice industry or dairy industry for the refurbishment or upgradation of the plants, because particularly in the dairy sector and juice sector, many plants are installed in 1980s and 1990s, and these plants are still running. These three-way valves, plug valves are still there. Actually, these valves should be there in the museum, but they are still in operation. There are homogenizers which are very energy inefficient. There are so many obsolete separators, those are consuming too much of power, and the spare parts are not available. So, what happens to the equipment life issues? We have to consider that energy inefficiency is a continuously recurring cost. Technological upgradation is not possible with the old equipments. High processing cost per unit of product is going to be there because of high cost of changeover of the parts and energy inefficiency. There is always a resistance from some of the customers that they don't want to get rid of the old homogenizer or old costly equipment. See, in our mindset at home also, we don't even get rid of our Amazon parcel box so easily. So you can imagine how difficult it is to convince our customers to get rid of the old equipments. But when we do a cost benefit analysis, then it becomes easy. So perishable industry, in perishable industry, if there is a market complaint, there is a brand image loss. That is much bigger loss than any other financial loss. Then another problem with a manual plant or semi-automatic, there is a word semi-automatic. So semi-automatic is that there is no MIS report. So operators are still making logbooks. There is chance that operator may show that he has cleaned 3 tanks and he has done CIP of 3 tanks in just 40 minutes with one single circuit CIP, which is practically not possible. But if it is written in logbook, nobody checks the timing. So these kind of things are not possible with in automation. Operators are not given that choice and that commands in his hand to play with the HACCP parameters. Utilities monitoring is another advantage. We can check section wise how much steam we are consuming, how much water we are consuming. I can say that those plants in 1980s in dairy particularly, they used to consume something like 3 liter of water per liter of milk processed. Now that ratio has come down to less than 1. So there is more than 3 times saving in the water itself because of the automation, because of the upgradation. And it is a national service that we are doing by putting up automation, I can say. Let's go next. Now see some of the examples here. There are some dairies where too much of flexibility is required. I want to take product here also, there also. I want to make some different product. So the flexibility goes on increasing, the complexity goes on increasing, and such kind of flow rates exist in the plant. And it is virtually impossible to know which port was clean, which line was clean, which bend is connecting where. And this is a hygiene risk. So that is where the automation plays a role. It is also required to fulfill the statutory environmental and food safety demands. As I said that we are saving tremendous amount of water. Now there is a zero discharge rule. So every liter of water consumed is a liability on the processor. What to do with that processed water also, even if you have ETP plant. So, and many times you are producing the product for your brand as well as other brands in co-packing. So the multinational brands who are going to come with you for co-packing, they will require these MIS reports because they want to have the peace of mind about their product how it is processed. Next. Another problem that we faced in automation is some unit operations, like some pasteurizers or some heaters, are in automation, but some things are in not in automation. Some things are still maintained manually with push buttons. So this creates a big confusion in the mind of operator. There is no discipline or no operating guideline which can be uniform in the plant. So we have to step by step upgrade everything to a fully automated plant, and we have to reduce the dependency on the operator skills and sincerity. Next. So these are some of the examples how the plant should be transformed from a very basic manual level. There is a heap of pipes versus a fixed piping with flow plates or with mixed proof walls. Next. So these are some of the clean installations. This is how the plant is operated through SCADA. Many times our plants that we deliver are so much automated that the operator has to only take a round periodically to check whether there is any breakage in the pneumatic lines or any abnormal noise from any of the pumps, motors, agitators. That's all they have to observe. Otherwise, everything is controlled from the central automation. One of our customer, I have convinced him not to switch on the lights in the night in the production areas. All the lights need not be switched on. Switch on only the necessary basic lights because everything is controlled through automation. That's big power saving. Next. So let's recap on the automation. It improves the product quality. It increases the equipment life. It reduces the product losses. It reduces the utility losses, prevents operator mistakes. Utilization of equipment is optimized. For example, you can properly uh, make a chart as to in 24 hours how many times you use the equipment, how many times you did the CIP. Then you come to know that yes, now if I operate the plant in this time of product time scheduling, then I have spare capacity for the tanks. I have spare capacity in the CIP. So that's another advantage. We don't over design if we are doing proper automation. It reduces environmental load. As I said, the water consumption is reduced, steam consumption is reduced. It reduces environmental load. It gives us a traceability and reports, and that will help management to take the decisions. And also we have to also do the analysis of the reports and do the further improvement planning or enhancement planning. And the first point is return on investment. I would like to share our case study here. I don't have time to go through each and every parameter of this case study, but when we did a case study in automated process plant, we have seen that the difference of investment cost from a manual plant to automated plant can be recovered in just less than 3.5 hours time, 3.5 years time. There is an of course advantage of the brand image. There is an advantage of flexibility, but even on the commercial scale, you can recover that money in 3.5 years. Thank you. Next.
So now we are entering the final phase of the webinar. So we will discuss some smart technology which are driving the beverage production. So let's discuss how these smart technology evolved. So we were around say 15 20 years back. We were working with flow plates or divert panels for our beverage processing plants. Then we migrated to automated systems with automatic wall clusters. Now, is that enough? Is is this the only point, or is this the saturation which we have achieved on the technology front? No. So now we are having systems which are smarter, which gives you a real-time monitoring of the product, and which can have a predictive control. So it itself understand the error and it minimizes and have an auto control philosophy. So I have just listed down some aspects of uh, manual batch process, automatic batch process, and an inline blending process or inline system where these smart technologies are uh, occurring. So, so if you see the automation level, so they are highly automated plants. They have highly controlled and accurate accuracy. The product consistency is very good. The labor requirement is very low. Even the hygienic level, if you say, then these plants are having a very high level of hygiene, and these plants are very concise, so they have a very small footprints in your process plant. And since you know that the land prices and the civil cost is increasing, these could be a good option for a larger and big scale plants to operate with, and it has a closer quality control over the manual as well as the automatic batch process. So we will discuss at Neologic. We have two such technologies which we are promoting to all our beverage customers. So we have uh, continuous sugar dissolver. So continuous sugar dissolving system is moving away from the big sugar batch dissolving or a raw syrup tank that you have in conventional beverages, to a continuous preparation of bricks starting from a capacity of 5,000 to 30,000 liters per hour. So there would be a flexibility of operation. And second, it doesn't have any moving parts, so all the mixing is done through radial jet mixing. So it is operational friendly and maintenance friendly. Then, with the help of syrup pasteurizer with regeneration facilities, these plants are energy efficient. Then we have also uh, taken care of the activated carbon slurry handling system and their disposing system. So this system is only confined to a very particular area where we are treating the syrup with activated carbon, and we are ensuring that there is no carbon carryover going forward into your further blending system or a ready beverage system. And we are also, and these systems are also having sweet water recovery, which enables you to have less product loss and a higher yield. So basically what we are doing is we are making the batch process into a continuous mode. Similarly, what we have done is we have uh, eradicated or we have eliminated the big juice blending tanks. Suppose you have a 40 kl line, 40,000 liters per hour juice processing line. So you imagine how much big your blending tank would be. So with this inline blending system, you can reduce your tank capacity with smaller ones, and then you have a premix over here, and then you can inline blend your premixes with your other raw materials, and which will then further connected to either to your ready syrup sections or to your pasteurizers, which ensures that you have a real-time monitoring of the breaks or other quality parameters. Then it is predictive control. So suppose there is some mismatch in recipe, so in a second, in a milliseconds, it will again recorrect or auto correct the recipe, and then send the complete product for further processing. These plants are having minimum human interventions. So all plants are highly automated with HMI based, and these, and since this setup is very small, so equipment footprint is less, and the CIP requirement is also very less. So it also reduces the chemical losses that we found in bigger while CIPing the bigger tanks or bigger CI or bigger objects. So in short, smarter technologies are now in trend and are delivering a state of art facility in the advanced beverage manufacturing processes. So so to recap what we have just observed during the seminar, we understand the importance of hygiene. Then we understand how we are implementing the hygienic principle during installation, and then we have also understand the automation part, why automation is important and how it is enforcing reliability and product safety into the processes. And we also have a glimpse of smart technologies which will be futuristic technology and which would be a self-reliant technology in beverage processing.
Okay, thank you, Ankit ji. Thank you, Ravindra ji. What a interesting and very nice session. We already have a lot of questions lined up. So I'll take one by one, whatever the time permits. The first question is from Mr. Mohan. Does Neologic work on new plants only, or the expansion and upgradation also you can do in the existing plant?
As I mentioned, both types of plant we work. Upgradation is actually more critical, and upgradation plants require more competence and knowledge because you have to solve the problem which is already there.
Okay.
And we are doing it for so many years now. In fact, we are known in dairy industry for doing the upgradation without stopping the dairy processing. 365 days the dairy is running, and still in the running plant we have done the upgradation.
Great, great. The next question is from Mr. Raju. Will your company conduct our existing plant audit from hygiene perspective and suggest us some changes or upgradation?
Surely, as I mentioned, that the upgradation requires detailed understanding of the operations and pain point areas, and why upgradation is required, what are the issues to be addressed. To do this, a plant visit will be required. So please share your details and your plant details with us, or we can have first maybe Zoom meeting or Teams meeting with your concerned team, technical team, and then decide the further strategy or action plan.
Okay, great. Next question is from Mr. Aditya. Will you be able to upgrade our semi-automatic plant? There was a term which you, Ravindra sir, mentioned about semi-automatic plant to fully automatic plant.
As I mentioned, that detailed analysis is required because many times we come across situation about the space constraint. I am not indicating here that the automated plant require more space. Actually, automated plant can be more compact. But so many times we come in a situation that there is no space for instrument mounting. There is no space for putting up the valve cluster. Or the height of the tank is so low that valve cluster installation, after valve cluster installation, we have to now raise the tanks. And then there is a height limitation on the slab. So all these things cannot be imagined or it cannot be put in a questionnaire. So detailed discussion and study is required.
Okay. Next question is from Mr. Mani. Can we also reduce the operating cost by converting semi-automatic plant into a fully automatic one?
Definitely. As I mentioned, there is no difference between the operating cost of a automated plant, greenfield automated plant and upgraded automated plant.
Okay, okay. Next question is from Mr. Dharma. Can we incorporate your continuous dissolving system in our existing batch type syrup system?
Yes, it is very much possible. We will have to understand your maximum peak and minimum processing need for sugar syrup. Based on the plant need and production requirement, we can suggest you the optimum capacity of the continuous sugar dissolving. And also, please keep it in mind that continuous sugar dissolving system need to be fed continuously with sugar from the warehouse or from your day storage. So
Okay.
based on that layout, we can suggest you suitably.
I think, Mr. Dharma, you must have received your answer for this. Next question is from Mr. Babu. What is the minimum size of plant your company can set up?
Yes, Ankit, can you take this?
See, it depends on the filling capacity as well as the number of products that you want to introduce with the same setup. So we can have the further understanding of your requirement, and base that uh, the shift or the production time that you may allow in a day. Basis that we will design and we can propose the minimum, what is the minimum capacity we can offer post discussion.
Okay. Okay. Next question is from Mr. Hemant Singh Sisodia. How AI is used in food and beverage industry?
See, AI, you can use artificial intelligence. Basically, artificial intelligence is analysis of your historical data, and secondly, real-time monitoring and suggesting the predictive control with these data. So our technologies like continuous sugar dissolvers or inline blending systems offer such type of added advantage in the modern juice processing industries, where it self-analyze the historical trends, and further it autocorrects itself, and so that it maintains the consistency and the reliability of the product.
Okay, I think Mr. Sisodia must have received his answer. Another question is from Mr. David. We have a setup in Africa. Will you be able to upgrade our system in African continent?
Yes, definitely. We have more than 15 installations in African region. Maybe it
Oh,
is Kenya, Zambia, Zimbabwe, Uganda. In many countries, we have our installation and multiple installations. So it is possible to cater to your requirement.
okay. Another similar question is from Mr. Ibrahim from Saudi Arabia. We are looking to set up a complete greenfield new plant in Saudi Arabia. Will you be able to help us? Do you have some similar installation nearby?
We have installations in Saudi Arabia, but I cannot say that it is a completely greenfield project because so far whatever requirement we have received are from the existing brands.
Okay.
So we have added a complete new section and new functionality and new auto upgradation. But
Okay.
we don't see any issue in doing a complete greenfield project.
Okay. I think this is one of the last questions. This is question from Mr. Gowda. He's asking about, we have already existing plan for the beverage. Will we be able to add tonic water or other areas into this particular plant?
Yes, definitely. That so if you have a juice blending system and then you want to add a tonic water line, then it is doable. Or you have a carbonated soft drink line, and if your product constituents are synthetic, then also we can use the same setup for processing of tonic water line.
Okay, great. Nikhil, can I take one more last question?
Yes, yes.
Yeah. So there is a question from Mr. Manikanchan. Ravindra sir mentioned that their observation is around 3 years return on investment. Can we discuss more on detail on that?
Yes, every plant is unique and every plant has some set of operations, like how many transfers, how many times the filling machine is operated, how many times CIP is done after the production, what is the CIP interval in the production. Based on that, it has to be worked out. So one calculation cannot fit for the other installation. But overall, it is 3.5 years, what as I mentioned, for a new plant of a medium size. So we can discuss it more.
So we can ask him to write down to us and have a
Yes.
Teams call or something like Zoom call. Yeah.
Yes.
Okay. That's it. Back to you, Nikhil.
Yeah, can we have the next slide, please? Yeah. So these are a few of the upcoming events wherein we are participating. On the 4th to 6th November, we will be participating in Gulf Food Manufacturing, and our stand number is SE4, Hall is Trade Center Arena. So you can meet us and you can take a look at our latest technologies. You can discuss with our experts in beverage industry and food processing industry. And the next webinar, next event is Drink Tech India, that is in India, Bombay Exhibition Center, Mumbai, that is from 13th to 15th November, and our booth number is F73. So you can visit Bombay Exhibition Center at our stall. We welcome you all to know more about our upcoming equipments and latest technologies. Also, I would like to give a heartfelt thanks to our esteemed speaker, Mr. Ankit Sharma and Mr. Ravindra Mahajan, for sharing their profound insights in today's session. And finally, sincere thanks to all attendees for your active participation and engagement. Let us continue driving innovation and excellence in food processing. We look forward to seeing you in the future webinars as well. Thank you once again for joining. See you all in the next webinar. Thank you all.
Thank
Thank
you.
you.
Thank you, participants.
Thank you.
Thank you
Bye-bye.
very much.